Awesome. Well, good afternoon and welcome to week 7. Hope you're recovering well. Took me a few days, but I believe it's worth it. And I think right now the tentative plan is that classes will be back in person by winter, hopefully. $5G boost yet? Is that for COVID? I don't think I use the phone network anymore. I've got my nice Pixel phone and it's just a Wi-Fi device. All right, so I mostly want to go over the midterm today. Midterms are graded, and I got them posted on Canvas with some feedback yesterday. But any questions before we start talking about the midterm, like questions on PA4, for example, or on 5G boosts? Microsoft ads in my sleep, yes. It's the microchips, man. Yes, you can create mouse event. You can capture mouse events on J panels or J frames, but I recommend doing it on a J panel. And just right click inside the panel, right? Maybe left click the panel first to highlight it, get the box around it, and then right click inside there and just add an event handler. And that should work the way you expect. Definitely welcome. I gotta change my profile picture sometime. That picture is like a year old. All right. Well, let's run through the exam. So first question was basically about overall class setup and creating the parts of a class definition and some constructors and some methods. And so I'll try to mention the main issues that I saw people running into. So not too much issue with this. Class name of Victor. And a set of integers. And they were supposed to be private, so private int. And so we got Shelley, Igor, and Byron. No particular initial values. 2 constructors. So the first constructor lets you specify values for all 3 of these. So to make a constructor, we're going to say public. We're not going to put in a return type like we do with a method. We're just going to put in the name of the class and then list any arguments with their types. So I could do, integer s, integer I, integer b, and then just make the assignments. So Shelley equals s, Igor equals I, Byron equals b. And that's a pretty standard constructor. Now, what you would typically see would be the argument names would be like integer Shelley which would make this assignment statement something like Shelley equals Shelley. Except this doesn't do anything, right? Making a statement like x equals x doesn't change the value of x. What we need to do here is that one of a few cases where we actually need to use the keyword this, and we could say this dot Shelley equals Shelley. And so Shelley without any prefix is referring to the most local version of this, the thing in the most tightly contained loop, or bracketed expression, which in this case would be the method declaration. So Shelley refers to the argument, but this dot Shelley always refers to the one in the class itself. So now we're explicitly doing what we want, which is set this variable equal to that variable. So that's where you see the keyword this. All right, and then it said can be constructed with one initial value assigned to Shelley, Igor, and Byron. So I thought that was pretty clear that you want a constructor that you pass one argument to, and that value gets assigned to all three of these integers. But there was still some misinterpretation, which I let slide. But here is the intent. Right, you can construct with a single value, and it sets all three integers equal to that value. So some people gave me 3 of these, one for setting Shelley, one for Byron, and so on and so forth. But you know, one argument assigned to all 3 instead of having to say, you know, value, same value, same value. So that's something you see, and it's just this idea of different signatures, methods, or constructors can have the same name, but you can have multiple copies based on the type of arguments that you send to them. All right, and then public methods, friend, torch, and villager. Okay, so the idea here is let's look at the friend method, which tells us if Igor is 0. So it's a Boolean. So you don't pass any arguments to this, right? So it's supposed to be a method with no arguments that tells you if Igor is equal to 0. So you could pass the value of Igor to this, but now it's more like a C-type function, which tells you if an argument is equal to 0, which is kind of a you know, superfluous thing to do, because if we want to know if something's equal to 0, we can just say equal equals 0, right? So this is part of the Victor class. It's a method. So if we have an object v of type Victor, we could just say v.friend, and it'll give us a true or false based on whether Igor is equal to 0. Well, which Igor? The Igor associated with that object v in this case, right? So when we write the code for this, we could just do something like if Igor equals 0, return true. All right, so if that's all you write, that will not compile, because the compiler will say this method's supposed to return a Boolean. If Igor is not equal to 0, you're not returning a true or a false. And so it won't actually compile, so you need to make sure that you're always returning a value. So let's put a false in here. And that'll work fine. Some other versions of this that will work, but might not be what you want to write. So just to think about other ways to do this, right? What I saw some people do is something like this. If Igor equals 0 is equal to true, return true. That works great, right? If Igor equals to 0, if this statement is true, then return true. That compiles fine, it runs fine, but it's a little superfluous, right? Because you're saying if this is true, right? Well, if this is true, you can just put it inside an if statement like that. And same thing if, I think I saw one of these. If Igor equals 0 is not equal to false, then return true. Works perfectly fine, does exactly the same thing as this, but there's a lot of extra stuff going on in here. So this is much more succinct, but let me show you an even more succinct way to write this. All right, you can do this in one line. Yep, there you go, perfect. You beat me to it. No, that's good. So yeah, this is a Boolean expression. It's true if Igor is 0, it's false otherwise. And so we can just put that as the argument to, or the value for a return statement, and that'll return true or false. Right. Now, any of these that you did, that's fine, but I may have given you some comments like, you know, think about doing it like this or that or something like that. But they all work, right? But as you continue coding and learning, you know, to code and working with new languages, right? Be thinking about different ways that you can do things and you know, dial in your sort of most natural approach. All right, and then the other methods are not terribly different. So torch sets everything to 0, so that's just a void method that sets all 3 integers to 0. And then a public method, villager, it's another Boolean, which returns true if Shelly is smaller than Igor and Igor is smaller than Byron. So again, we could just return Shelly less than Igor and Igor less than Byron, right? Or you could break this out in a series of ifs or if-else's or things like that. If you were to actually write this, I didn't see anybody do this. But if you do this, I'm not sure that will compile either. Because I don't know if the compiler will actually analyze this and say one of those statements is going to fire. I think it's just going to say, if this is false, we won't return. If this is false, we won't return. Hey, there's no return statement. So sometimes you have to kind of nurse the compiler along a little. And same thing if you do an else. And the else is unnecessary here. So let me do this one too. Also works perfectly fine, compiles fine, runs fine. But if this statement is true, you're going to return, and so you're never going to get down here. So if I get here at all, I know that my if statement failed. I don't actually need the else, which means I can, you know, not indent all of this an extra measure, and that can keep my code a little cleaner, a little easier to read. So just things to think about. Let me see if there was any other thing on that. No, but I lost my notes again. All right, where are they? There they are. All right, so let's see. Okay, so that's one. 2. So question 2 was accessors and mutators. Okay, getters and setters. So the whole idea is that if I make this class Bach and I have these integers declared as public, then I can access them directly up here, and I can read them, and I can give them whatever values I want, and so on. But in some cases, right, these are being used internally, and we may want limited control, limited access to these variables, but maybe we want to, you know, control whether they can have negative values or something like that, or we want to do something when the value changes. We want to change something inside our class, and so on. So information hiding, right, the idea is let's go ahead and make these private. So public class Bach, we'd have private int hit and hit2, but then we create methods for accessing these things. So we would do something like public integer get hit, and generally when you write accessors, they're called get, starting with a lowercase g like all methods, followed by the name of your variable that you want to return the value of. But if you're using camel case, the first letter of that variable is usually lowercase. You go ahead and you uppercase it. So if your variable is called hit lowercase, it would be get hit with an uppercase h. That's just convention, but it's pretty standardized. And in fact, in Eclipse, if you want access to a private field and you try to get that access, and the compiler says you don't have access to that, it'll actually give you an option for, would you like me to write some accessors and mutators for you? And if you click yes, it will go ahead and it will create methods like this, and it'll use this naming convention. It'll be get variable or set variable. So this lets us, instead of saying, you know, x equals 5 times mercury.hit2, we could do something like x equals 5 times mercury.get hit2. And then to change values, we have mutators. So a mutator generally doesn't return anything. It's called set instead of get. And it takes an argument. And we could call this argument anything we want, but usually this is another case where we'll use the keyword this. So we'll give an argument, which is the name of the thing we're trying to set or mutate. And so we would say this dot hit equals hit. And these are one-line methods, right? But the advantage is that instead of going in and, you know, just manipulating some field directly, we go through a method. And so instead of saying mercury.hit equals 7 plus x, we could say mercury dot set hit 7 plus x. Yes, and it allows the setting to be used as a trigger of some sort of other thing to do. So there might be something in our class where we want some something to happen whenever this value has, you know, certain value, or it exceeds some threshold or something like that. Or we want to change the state of the system somehow based on the value of this, and so we could do all of that inside our mutator. Or, you know, like we did with rectangles and triangles, we could say, well, you know, the value of hit should never be less than 0. So we could double check that in here and do something appropriate if 7 plus x was less than 0. So one thing I saw a number of people do that was a little worrisome was something like this. Right, where they used an assignment statement, and on the left side of the assignment they use an accessor. Right, so this is an object. This is a method inside the object, and the return value from the getHit method, the accessor, is an int. So this is an integer. It's a number. And trying to set that equal to 7 plus x, that's a syntax error. That's like saying 15 equals 7 plus x, right? The sentiment is clear. You're trying to take 7 plus x and cause that to be the value that mercury.getHit would return. But that's like anti-entropic. That's trying to run the equations backwards in time or something. That's just not how Java works. So we have a separate method, which is a mutator, which would take the argument 7 plus x and then set the variable equal to that. All right, so that was the main thing with that. There were more cases where the accessor was good, but the mutator was bad than the other way around. But a lot of cases, both of them were fine, which is better. All right, generating an exception. So the normalized Gurgle factor. So this method takes in an array of integers, sets Gurgle factor to 0, and then goes through and adds up each of those integers to this running sum, and then divides that into 1939 and returns that. That's the normalized Gurgle factor. And it notes that this method could potentially generate an exception. So where can the exception occur? Well, it can't happen here. This is declaring an integer and setting it equal to 0. Since that cannot generate an exception, don't put that inside the try statement. This, it turns out, can also not generate an exception because I starts at 0 and it goes up to the length of the array minus 1. If the array has no elements, then this would be a 0, and I less than 0 would never fire. We would never do this. And if if the length of the array is 10, this will go from I equals 0 through 9, and each of these will be a valid access. So there's no case in which this is going to generate an exception. So this does not go inside a try statement, and neither does integer beaker, and neither does return beaker. The only statement that can generate an exception is right here, because GF could end up being equal to 0, and dividing by 0, that'll throw an integer exception. So this is the statement you want to put inside a try statement. So try curly bracket beaker equals catch exception E, and in the exception case you want to return negative 42. So really, to be as tactical as possible, you just want to put a try statement right around here, have a catch statement to return minus 42, and then put this outside, put all of this outside. Now I gave you credit if you did something sort of wider sweeping than that. Including what about half the class did, which was put the entire method inside a try statement and then put a catch at the end to send out negative 42. But you don't want to do that, right? That's generally considered sloppier code than you want. Put your try statements right around where you might have an exception. Also, don't just add a throws keyword here. If I say throws exception, that will let me compile this code, but when I run it, if I divide by 0, it'll still throw an exception. Right? So we want to try catch block, and we want to make sure that they're as small as possible. X is a primitive array. I don't think it can be null. That's a good question, though. But I think this is still a primitive. But that's a good question. Try that. I'm curious now, actually. Let's try that. right, yeah, if you don't initialize it, it won't let you compile it. And I don't think it will let me initialize it. Hey! Ah, cool, okay. So it is possible to get an exception on that. Alright, so if you were thinking that, then you were being extra smart. But I didn't take off if you put this in a try-catch block. If you put that in a try-catch block. I did take off though if you did not have that in a try-catch block. But cool, that's a nice observation. All right, so yeah, yeah, I'm pretty sure a primitive itself can't be null, but apparently an array can. Yeah, I'm not sure I approve of that, but that seems to be what the compiler does. Added to the list of hmms about Java. All right, so question 4. This was probably the most challenging for people on the test. So you were writing something like a cat program or a head-10 program, a Java program that will copy files, one file into another, but only copies the first 10 lines. Right? So yeah, right. JavaScript. So read from source, write to destination. Up to 10 lines, but if source is shorter than 10, just copy the whole file. So this is like cat, right? But with this restriction on how many lines it will write. So it's a program named pepper.java, so it's all going to sit inside a class, pepper. And we need a main program, so our usual public static void main. With an array of strings for the arguments. Alright, so we're going to want to open up a scanner to ingest from source and a print writer to output to destination. And so this is going to be args bracket 0, args bracket 1. We don't want to use args bracket 0, args bracket 1 unless we know that those things exist. Right? If we don't check the length of the arguments array, we don't know whether or not source and destination have been specified. So probably right up front, let's just check the length. And if arg's length is not equal to 2, let's just return. And I didn't say what to do in that case. I just said don't throw an exception. So you could just return silently, or you could print a message saying, you know, here's how you're supposed to use this command or whatever. But as long as you don't throw an exception, you're okay. So so that takes care of the case where you don't have 2 arguments. And, you know, you could do less than 2, so that if they put in extra arguments, you don't throw up on them for it, but something like that. All right, and also, you know, going back to thinking about style, right? I'm not going to put the rest of my code in an else statement, because that's going to indent everything further, and it's needless, right? If my length is not correct, I'm going to return. I'm not going to see anything that comes after that, so I can make all the rest of my code just, you know, first level indent. And that's going to compel me to do this check first instead of if arg's length equals to curly bracket, everything else indented an extra level, end curly bracket, here's the else part that I have to go down my whole page to read, right? Thinking towards readability, not just for other people, but for myself, right? Going through my code. So if you can dispense with a case quickly, do that, right? And now everything from here on down is just, you know, going to happen because we know we've got two arguments. So we're going to need a scanner, and we're going to need a print writer, and you're going to need some imports. So import whatever. And again, you know, ideally you make your imports as precise as necessary. Java.io.file as opposed to java.io.star, which will import everything, and it makes the memory map more complex and harder to look through when you're compiling and so on. But import it in some way, shape, or form. Alright, so we've got a scanner and a print writer, so we need to construct these based on the arguments. These have got to go in try-catch blocks, right? The compiler will force you to do that. And again, putting a throws up here is not going to be the same thing, because that's just saying it's okay if my main program throws an exception when I run it. Yeah, good comment. Early return in edge cases, it does seem more ideal. And I don't have to think as hard, right? I don't want to remember as I'm writing code, oh yeah, and don't forget to do the else statement, right? And that's typically where you get into things where, you know, you compile and it says missing curly bracket, and now you start putting curly brackets in at random or deleting them at random, and now you're just, you know, holding your breath that your code's gonna work. So the less indenting you have to do in some case, the better. But that doesn't mean don't indent your code. Alright, so there's a scanner and a print writer, so we're going to put these inside try blocks. So make a scanner from a file of args bracket 0. And again, I didn't say what you had to do if you couldn't open the file. You could print a message saying, you know, can't open args bracket 0, or you can just return as long as you're catching it. So that'll open the scanner. I can't put the declaration of scanner inside here because then the scope is limited to from here to here. And once I get outside, SC will be gone. So I have to declare it outside, and then I can give it a value here. If you're doing this, this would actually catch the case also where args doesn't have at least one element in the array. But then if I try to print can't open args bracket 0, I'll be getting an exception inside my catch statement and all that. So, but okay, so this will either open the scanner or I'll return right here. So this is like preamble. At this point, I have a scanner object. Now I need a print writer object, right? So try pw equals catch, and so on. And now I've got a scanner object for reading in, I've got a print writer object for writing out. And we're ready to do our thing with that. So what is our thing? Copy the first 10 lines from source to the file destination. Okay, lines tells us we want to read one line at a time. And scanners have a method called getNextLine, or nextLine, that gets the next line for us. So while SC, and how do we know if there's another line? Well, SC has next line. Let's read next line into a string, and then let's just save it. pw.println. All right, so this is a perfect file copy, ignoring this 10-line limitation. This will read everything from what the scanner was opened on and write it into what the print writer was opened on. You don't need to check to see if the print writer file exists and delete it if it exists or anything like that. If you open a print writer on a file, if it exists, it gets zeroed out. If it doesn't exist, it gets created. So they sort of take care of that overhead for you. And this you could also do more succinctly as just pw.println sc.nextLine. So scanner object, next line method, call that. This returns a string. Print writer object, print line method, pass that string to it. It writes the contents into the file. And you definitely want next line. If you just do next, that's a single word. And since we're going to be counting lines, we want to make sure that we're reading up the entire line. You can do print ln with a string, or you could say print line plus \n. But that's also Unix specific. If you're on a system like DOS that uses, chars returns for line endings, this will do the right thing. We would need to do something different if we're trying to add a \n ourselves, for example. All right, so that copies the whole file. What if we want to restrict to 10 lines? So let's just count, right? And so I'll do integer lines equals 0. And so remember 224, we talked about this idea of try to fix in your mind what the variable means. So what is lines, number of lines? No, more specific than that. I'm thinking of this as the number of lines I have currently printed to the output file. That's why I'm initializing it to 0. If I initialize it to 1, it's probably meaning the number of lines that will have been written after this current iteration of the loop is done. Right? So lines equals 0. Number of lines written. That tells me that after I write that line, let's increment that value. So set lines equal to lines plus 1. And that also tells me I want to exit after I've written 10 lines. So now I can say something like if lines is equal to 10, let's break out of the loop. And you can do an edge case test. Suppose I wanted to write a single line. If I initialize lines to 0 and I say if lines equal 1, well, I'll print one line, increment lines to 1. If lines equals 1, yeah, I'll break out at that point. All right. Most people got this perfect, by the way, as far as, not doing 9 or 11 lines and so on and so forth. So that's good. So this will loop forever, and then when I get to 10, it'll break. If you don't like break statements, right, you could say, well, SC that has next line, and lines is less than 10, for example. That would work. And there's lots of ways you can slice and dice that. All right, so this will exit at some point, either because has next line failed, because we finished reading the source, or because we wrote out 10 lines. So now you got to close your file. And if you don't close, your output that you've printed may not actually appear in the output file. So we looked at examples of that. So make sure you close your print writer before you exit. All right, let's see what else do we have on that one. You can also flush. I believe that will do the same thing if you flush throughout. But if you're going to flush, you may as well close too. But yeah, I think if you flush, it will go all the way out. There's other ways to do I/O, right? So you can do a buffered writer, you can do an output stream, you can use the write method and all kinds of other stuff. And I'm okay with doing things differently from how we do it in class. But in almost all cases, when people did that, the code they came up with actually wouldn't work. For example, if you do pw.write, you have to add a new line to the end of it. If you just write line, well, line doesn't have a new line. When you read it with next line, and then when you write it, everything would come out on one line. So things like that. But this should work. Let's see. Yeah, I think that was pretty much it. All right, so that leaves us with question 5. So the short answer, true, false, kinds of questions. So let's see. Best practice is to have methods begin with uppercase letters. That's actually anti-best practice. So classes should begin with an uppercase letter. Methods should begin with a lowercase. That's just the convention right now. It's not enforced by the compiler. It's kind of a de facto standard for naming conventions. So method should begin with a lowercase. So part A was false. Question B, a class named Dietrich must be placed in a directory named Dietrich. That's false. It would be placed in a file called dietrich.java, but there's generally no requirement for what kind of directory it's in. The notion of directories is sort of outside of Java until we start talking about packages. What would you type to compile a class written in a file named amulet.java? That would be javac amulet.java. Yeah, and then do Microsoft work, and everything is uppercase convention. Microsoft still doesn't seem to understand uppercase, lowercase. Like, if you try to change the case of a file by using F2 to type in the new one, at least last time I tried it, it didn't seem to work. So you have to name it to something funny and then name it back. Is that still the case? Oh no, it seems to work now. Okay. Yay, Windows 10. Alright, so javac amulet.java. What's the third block that goes with try catch? That's the finally block. So you've got try these things, you've got catch if an exception happens, and then finally, which gets executed in either case, including the potentially weird case where if one of your blocks says return at the end of it, it'll still go down and execute the finally block before that return statement is executed. I don't know why. But so that's the third block with try catch. What's the difference between integer exploding sock or int exploding sock and integer exploding sock? So this is about primitives, right? So exploding sock is an int. Int is one of 8 primitives. So there's int, longs, shorts, characters, bytes, booleans, floats, and doubles. And those we can declare a variable by just saying, int exploding sock. And we can start using it right away. We don't have to construct it. Whereas an integer exploding sock declares this to be an object of type integer, but its value is null until we say equals new integer. So integer is a class, which is a heavier weight object. Int is a primitive, which is a very lightweight object. It basically just holds typically 32-bit value for an int. Whereas this is a whole class, so it comes with a bunch of methods and some fields, and we've got all this machinery to go along with the integer value stored inside this object. All right, do we need to worry about memory leaks in Java? Pretty much no. So in the sense that, in C you use a malloc statement to get a chunk of memory, and then if you lose the reference to that, right, that memory is lost. if you set x equal to malloc such and such, and then you change the value of x, that chunk of memory is still allocated, sitting out there taking up resource, and there's no way to get to it, right? That memory will never get reused until your program exits. In Java, there's the garbage collector, which will go around and it will look for exactly things like that. Here's an object that nobody is using. I'm going to reclaim the memory for that object. Right? So in that sense, you don't worry about memory leaks. We never have to worry about calling a free statement when we're done with an object. When we're done with an object, just don't reference it anymore, and the memory gets reclaimed. So you can dig deeper into that, as I did with someone over the weekend, and there's other levels to that. But at a first order, we don't really deal with memory leaks in Java. Under the hood, the C code probably IDs int as a C primitive int, but probably has C++ class called integer. Is that correct? Yeah, that's plausible. I haven't looked at the source code for Java. I've looked at the source code for some classes. I never dug into the source for the JVMs themselves. But that seems plausible. Alright, consider the statement public void Eloy integer x. Is this a method or a constructor? So which one is this? What is Eloy? That's a method. How do you know? Because it returns something, right? It happens to be returning void. But it's returning something. If the word void was not here, if it was just public Eloy, that would be a constructor. Because constructors look exactly like methods, except they don't specify a return value. So the fact that it says void, that tells you that that it's returning a value, so it's a method. Even though it's, you know, got an uppercase letter, which methods aren't supposed to, it's still definitely a method. I didn't mean to put a semicolon here. That's kind of weird. So that's a method. Yes was not a valid answer here, right? This was not a yes/no question, which is why it didn't say Y or N. Technically, and maybe if this was CS215, I would have given credit for yes, because technically, you know, the disjunction of is this a method and is this a constructor is true, but I was looking for either method or constructor for the answer there. All right, is the following a valid beginning of a main method declaration? Public static void main string bracket bracket haha. Absolutely. Right, that's perfectly fine. That'll compile. That'll be a main method. We usually call this argument args, but that's not required. Right, it's just a variable name. Just like in a catch statement, we usually say exception something like e, but we could say eek, you know, or haha or something. It's just a variable name. So that's perfectly fine. Now, if we uppercased m, that's not a main method, right? The main method has to be a public static void main lowercase m with one argument, which is an array of strings. So yeah, this is perfectly valid. How would you declare a variable named try-catch to be a linked list of rects, assuming rect is an existing class? So this is linked list. And this is a generic class, so it takes a single specifier, which is the kind of thing you want to put in your list, which for us is a rect. So that's the declaration of the variable. It basically says what kind of object this is. And then in part J, how would you take the declared variable in I and construct the variable try catch? So the constructor is where we use the new keyword. And so we say new, the type of object that we want, which is a linked list, which has to include the generic specifier, what kinds of things, and then the arguments, which for us there's no arguments, so just a pair of parentheses. And so, you know, to be perfectly precise, that was the answer for I, that was the answer for J. Now, if you did this in one line, linked list rect try catch equals new linked list, right? I gave you credit for, okay, you had the constructor, you just put it in I instead of J. And so I granted a little bit of slack there. But what I was being picky on, and I wasn't picky about most syntax, but I definitely wanted to see the angle brackets and the parentheses here, just because those are kind of peculiar with generics. So I was looking for those. But for the most part, in the exam for syntax, I was trying to be fairly relaxed. That was an exception. All right, questions about any of that? That like took us exactly to 250. All right, so we'll start talking about sockets and network communications tomorrow, and we'll create some servers and play around with them. We'll talk about client-server model in general and start developing some Java code, which will help us with PA5 when we add network communication to our dots game. So have a good rest of the day. I will see you tomorrow.